Hey everybody, Mr. Piercy here with part 2 of our lesson on identifying lines and angle pairs. So in the previous lesson we talked about more about lines, parallel lines, perpendicular lines, and skew lines. Keep in mind the difference between parallel lines and skew lines. Parallel lines are coplanar, skew lines are not. Now, in this lesson, what we're going to be looking at more are angle pairs formed by a transversal line. And if you remember the definition from the previous video, a transversal line essentially is just a line that is going to intersect two or more other lines. And the angles that are formed from those intersections are specifically what we're going to be looking at now. Now, the definitions that we see here are pretty much the definitions that you copy down in the previous set of notes, where angles that are corresponding, they're called corresponding angles because they occupy corresponding positions in the figure. Now, think about it like this. If you are standing here and you walk the length of the transversal line, let's say it's a road and you're walking your way to school and you have to cross the street where angle 6 happens to be sitting. Well, there's a business or something that's sitting right there. So as you continue walking, you get to another stoplight and you notice across the street here in the same spot is another business. Maybe there's a taco truck there or something. I don't know. But they occupy the same place at their respective intersections with the transversal line. And that is why they occupy corresponding locations. That's why they are referred to as corresponding angles. Now, corresponding angles actually have the most sets of angles that we could have. Every time we have intersections like this, there's always at least 4 pairs that we could identify. Obviously, the 2 and the 6 are corresponding angles. So let's see if I can do this with symbols here. So I'll put a triangle here and a triangle here to represent that those are corresponding angles. We'll put a circle here and a circle here, and let's do a quadrilateral and a quadrilateral. So all of those are types of corresponding angles. The next one, alternate interior. Now I really do like the way that these things are named. The words alternate interior kind of help describe where they are in a figure. The term or the word alternate in the angles that we're talking about now refers to that they have to be on different sides of the transversal line, and interior means they must be in between my other 2 lines. So here, angle 4 and angle 5, you can see they are on opposite sides of the transversal line, and they are in between the other 2. Hence, alternate interior. An alternate exterior is pretty similar, except instead of being, so the angles are still on different sides of the transversal line. However, now because they're called exterior, they're not in between the other 2 lines. So angle 1 and angle 8 that we see here are alternate exterior angles. Now, at this point, I do want to draw your attention to the blue and red transversal lines that we see on the left side of the screen here, because I do have a tendency from time to time for students to confuse, particularly alternate interior, but more often, for some reason, alternate exterior. That's the one I see confused the most. If we look here where angle 1 and angle 2 are located, well, I have had students try to justify saying that those are alternate exterior angles. I mean, they are in the exterior region of the figure, and they're definitely on different sides of the transversal line. Now, unfortunately, we wouldn't classify these 2 angles as alternate interior or alternate exterior angles because, well, they're not really using both of the lines associated with the transversal. So because they're not really using both of those lines, a better way of describing them would actually just be as a linear pair. And that would go for the same thing for angle 3 and 4. Those would not be alternate interior angles. Those would really just be another linear pair. So keep that in mind as we go through learning how to identify naming these things. And finally, the last one that we looked at, so let me correct this here. That talking bubble shouldn't be going here. It really should be going here. Because same side interior angles are really just another way of talking about consecutive interior angles. So I like the term same side angle better than consecutive interior because to me, what this angle is taught, or what these pair of angles are referring to, are angles that are on the same side of the transversal line and inside of the other two lines. So to me, it just makes more sense if you're referring to angles that are on the same side of the transversal line. Well, let's just call them same side interior angles. But consecutive also does work, and again, it's half, 6 of one, half a dozen of the other. Pick up a book and you might see it labeled one way, you might see it labeled the other way. So I do have a tendency to probably refer to same side interior angles more often than I do consecutive interior angles. But if you tell me one or the other, I know what you're talking about. So you can use either one that you feel more comfortable using. So this last part here is really just, can you identify where they are? Now, before we get going, I do want to talk about the figure that we're looking at here on the right. We have 3 lines that are intersecting each other. Now, each of those lines fits the idea, fits the definition of what a transversal line is. So let's take a look at this line that goes here. Well, that line, let's call that line A. We'll call this line B, and we'll call this line C, just for the time being. Well, line A would be considered a transversal line to line B and line C because it crosses both of them. If I said line B is my transversal, well, it would be a transversal line to line A and C, the way I have them labeled. Okay, so I just want you to understand that a transversal line, the diagrams don't always have to look like what we have seen so far in our illustrations. Now, moving on, let's talk about how we actually identify them. It's really just based off, can you remember what the definition of it is, and therefore identify them appropriately. Now this diagram has made it a little bit simple for us because the horizontal looking line is really the only transversal line that we have to worry about because those are the only numbers, or those are the angles that have been numbered for us. So if we're looking at it like that, well, let's look. So corresponding angles, part A. Angle 1 has an angle that it corresponds to. And here is angle 1. And the angle that's in this, so again, if we're just kind of walking down the road, what's in the same spot when I get to the next intersection? Well, that would be angle 3. So angle 1 and angle 3 are considered corresponding angles because they're in a corresponding place at each intersection along the transversal line. So here are the examples of corresponding angles, at least in this diagram. So what I want you guys to try and do is just, now that you've had an idea of looking at it, maybe just go ahead and pause the video now and just see, can you identify what the other angles are? And when you're done, come back. Okay, so let's take a look at the next one, alternate interior angles. Now, alternate interior angles say they must be on different sides of the transversal line and contained within the other two, or in between the other two, I should say. So angle 2 has an alternate interior angle that pairs with it, and that would be angle 7. Angle 3 and angle 6 would also be alternate interior angles to each other. So, next one, alternate exterior angles. Well, those would be angles on different sides of the transversal line, but outside of the other two angles, or the other two lines, I should say. So angle 5 has an alternate exterior angle pair that it goes with, and that would be angle 4. Angle 1 and 8 would be the other pair of alternate exterior angles in this diagram. And finally, consecutive interior or same side interior, however you want to say it, those are angles that are going to be on the same side of the transversal line and contained within the other two, in between the other two lines. So in this case, angle 2 and angle 3 would be same side interior or consecutive interior, whichever you want to call it. So would 6 and 7. Now, if you haven't already answered it, let's just go ahead and take a look at these two here at the bottom. If you want to try and figure them out before I reveal what they are, go ahead and pause the video now and come back when you're done. But let's take a look here. Angle 3 and angle 4. So here, because this line is the one that crosses the other two, that must be considered the transversal line in this case. So 3 and 4 are on the same side of it, and they're inside the other two lines, so those are either going to be same side angles or consecutive interior angles, depending on how you want to refer to them. Now in number 7, again, I'm going to go ahead and say, well, this line here must be the transversal line, because that's the one that crosses the other two. So angle 1 and angle 2 are on different sides of it, and they are outside of the other two lines, so those must be alternate exterior angles. There it is. So that's pretty much it as far as how we're going to be using the lines that we have, whether they're parallel, perpendicular, or otherwise intersecting, and using those to say, well, based off of where they are in a diagram, they are now going to be classified as this type of angle. So it's really important that we understand how to identify them, because this here, what you're seeing, is going to be one of those concepts in geometry that don't really go away when we're done talking about it. When we're moving on in further elements in our geometry curriculum, this is going to be one of those things that just happens to pop back up from time to time and doesn't really announce itself. It doesn't say, hey guys, remember me. I'm the so-and-so type of angle. You'll have to be able to look at the diagram and say, oh, because of this, we must be able to make this and so and so. So that's one of the reasons why I want to make sure that you have a good understanding of what these angles are. So moving on, this is about where we're done with this particular lesson. We'll follow it up next time with parallel lines and how those interact with transversal line. What happens to the angles when my non-transversal lines are parallel to each other? But as always, again, any questions or comments or thoughts that you might have had, share them with me, share them with the other students in the Google Classroom. And until next time, guys, thanks for watching. See you soon.